Okay, so let's continue with more math. Yay! If you already have the values for Q and W just like your previous problems, madali na lang kasi i-add nyo lang yung dalawa para makuha yung change in internal energy. However, in the real world, not everything is given to you. Ngayon, ang tanong, paano natin measure experimentally kung ano yung heat at saka yung work na nangyari habang nagpo-proceed yung ating chemical reaction? To know that, or to calculate delta U, we must know the values and signs of both Q and W. And Q, we can determine later on, makikita natin, by measuring temperature changes. Let's focus first on W. Para malaman natin yung mga important na values at signs for W, we must first know whether the reaction occurs at constant volume or constant pressure conditions. Para mas maintindihan natin, let's look at the explosive detonation of sodium azide. So pag nag-detonate yan, makakaproduce tayo ng sodium and lots of gases. So recall our lesson in gas laws. Kapag meron tayo nung first na example, kapag constant yung volume natin at nag-produce ng maraming gases, ano ang mangyayari? Kakaroon tayo ng increase in pressure. However, kapag meron naman tayong constant pressure with a movable piston, kapag nag-produce tayo ng additional gases as a result of the reaction, mag-adjust yung ating movable piston so that the pressure will remain constant and what we will have is a change in volume. Recall that in physics, para magkaroon ng value yung work, kailangan merong displacement or change in position. Ganun din kapag tinitignan natin yung work in terms of gases. In the first picture, makikita natin na walang change in volume. Kasi constant nga yung volume niya. Ibig sabihin, kapag constant yung volume, we can relate it or we can say that there is no change in position. Ibig sabihin, ano ang masasabi natin tungkol dun sa work dito sa ating first example? We can say that there is no work done. Or, yung ating PV work as defined dun sa taas ay 0. Therefore, since delta U is equal to Q plus W at yung W natin ay 0, your change in internal energy is equal to the heat at constant volume. Yung subscript na yan na makikita natin dun sa ating Q just represents that the reaction is happening at constant volume or there is no volume change. On the other hand, yung second picture naman is an example of mechanical work done by a gas. So, since dito makikita natin na meron ng change in volume na nangyari habang nagpo-proceed yung ating reaction, we can say that there is also a change in position. That means, going back to our equation, delta U equals Q plus W, meron na ngayong value yung ating W and we can calculate for that using the formula, the pressure is constant, times the change in volume, which is essentially similar to the force and the displacement of our system. So now, this may be a source of confusion. Baka pag nakalimutan nyo, biglang magkapalit-palit na naman ang signs natin. But take note that the formula for W is negative P times delta V, which gives us delta U equals Q minus P delta V. Bakit tayo merong negative sign dito? This is just in keeping with the conventions that we discussed previously. Let's take a look at the picture on the right. An expanding gas pushing back on the atmosphere does PV work. So, meron tayong P delta V. So, since nag-expand yung gas, ano ang magiging value ng ating P delta V? Mas mataas yung V final sa V initial, ibig sabihin, ang ating delta V ay magiging positive. Tama? Ngayon, ang ating pressure ay ang pressure na externally ina-apply dun sa ating system, which means pressure is also positive. Kapag ang gagamitin nating formula is just P times delta V, an expanding gas would have a value of positive for its work. Tama ba yan based dun sa ating conventions? Hindi. Bakit? Kasi sabi natin, if the system is pushing outward, magkakaroon tayo ng positive na change in volume, the work must be negative. And how do we do that? So in keeping with the sign conventions, instead of W being just equal to P times delta V, we equate W to negative P delta V, so that our work would be negative if it is expanding and our work would be positive if it is contracting. So just to define some terms, since pressure is constant at kaya nag-a-adjust yung piston ay para magkaroon ng equilibrium pressure between the pressure outside and the pressure inside your system, P is just the external opposing pressure. And your delta V is the change in volume of the container, which is just final minus initial. Okay, let's try to answer this. Determine the work done in joules when a sample of gas expands from 552 ml to 891 ml at constant temperature. There are three conditions. Letter A, against a constant pressure of 1.25 atm. B, against a constant pressure of 1 atm. And against a vacuum for letter C. Meron tayong conversion dito, which is 1 liter atmosphere is equal to 101.325 joules. So first of all, we determine what delta V is. That would just give us 891 ml minus 552 ml, which is 339 ml. Or para mas madali, i-convert na natin siya to liters. So for letter A, our external pressure is 1.25 atm times 0.339 liters, and we use the conversion factor. 1 liter atmosphere is equal to 101.325 joules, and cancel the units. If you calculate that, you will get negative 42.9 joules. I use only 3 sig figs because 3 sig figs ang least number of significant digits natin. At since multiplication yan, then we will have 3 significant digits in our final answer. For letter B, it's the same change in volume, but this time our external pressure is 1 atm. Multiply that by our change in volume, 0.339 liters, and then convert using our conversion factor. And when you calculate that, you will get 34.3 joules. For the last item, same ang ating values except that it expands against a vacuum, which means external pressure is 0 atm. And when we compute for our work using the same formula, we will get 0 work. So try to answer this on your own. A reaction taking place in a container with a piston cylinder assembly at constant temperature produces a gas, and the volume increases from 125 ml to 652 ml against an external pressure of 988 torr. Calculate the work in joules. Again, the same conversion, 1 liter ATM is equal to 101,325 joules. So try to answer this on your own. A reaction taking place in a container with a piston cylinder assembly at constant temperature produces a gas, and the volume increases from 125 ml to 652 ml against an external pressure of 988 torr. Calculate the work in joules. And the same conversion, 1 liter atmosphere is equal to 101.325 joules. Ngayon, mag-focus tayo more on constant pressure conditions. Bakit? Oftentimes, reactions are carried out at constant pressure conditions kasi medyo mahirap gawin yung constant volume conditions in the laboratory. Kasi kailangan mo ng very, very strong na lalagyan, especially if you're expecting to produce lots and lots of gases and the pressure will increase tremendously. Itong i-define natin, the next quantity will help us when we're trying to determine internal energy changes for experiments or processes conducted at constant pressure. Dinedefine ang thermodynamic quantity called enthalpy or H as U plus PV. Kung paano na-derive yan, hindi ko na muna i-discuss kasi baka sumabog yung ating mga utak. But take it as it is, H is just equal to U plus PV. Enthalpy is also a state function like internal energy. So, kahit difficult i-measure yung exact enthalpy of a system at a given time, pwede naman nating i-measure yung change in enthalpy using experiments at madali lang yun magagawa. So, if we look at change in enthalpy, we can get another equation which is just change in internal energy plus your PV work. Tanong sa inyo, di ba parang familiar itong right side ng ating equation? Papaalala ko sa inyo kung bakit siya medyo familiar. So, kung matatandaan ninyo, pinakita na natin itong equation na to, which is your change in internal energy is equal to the heat plus work or minus P delta V. At ito ay, kung mabalikan natin, this is the equation for mechanical work done by an expanding gas. And this is at constant pressure, so just to denote that this is the heat at constant pressure, we put the subscript P. So, kung susubukan natin na ilagay itong terms na to on one side of our equation, and isolate all the other remaining terms on the left side of our equation, what will we get? Let's take a look at what will happen. So, ito ay magiging negative QP, negative delta U minus P delta V. At kung tatanggalin natin lahat ng negative sign, that means QP equals delta U plus P delta V, which is now similar to this equation. Ano ngayon ang masasabi natin tungkol sa change in enthalpy at doon sa ating kanina pang pinag-uusapan na heat at constant pressure? We can now say that at constant pressure, the heat or Q sub P is defined to be equal to the quantity called change in enthalpy. Ito ngayon yung maganda kay change in enthalpy. If we are able to measure it and we meet certain criteria, pwede nating masabi na ang change in enthalpy natin is approximately equal to our change in internal energy. Kailan nangyayari yan? Number 1, kapag hindi involved ang gases sa ating chemical reaction. Bakit? Kasi kung hindi involved ang gases, most probably this part of our equation will be 0. Another one is if the total amount of moles of gas does not change in the reaction. Bakit? Kasi kapag hindi nag-change ang moles ng gas, tandaan nyo yung gas loss ninyo, most probably the volume will also not change. And we can also assume that your change in enthalpy is equal to your change in internal energy when your PV work is negligible compared to the heat, even if the total moles of the gas does change. So, for example, sobrang liit lang ng adjustment sa volume na naganap, pero sobrang laki nung heat na na-release ng iyong reaction, then you can assume that your delta H is equal or approximately equal to your delta U, even if there was a slight change in your volume or PV work. At makikita natin na in future lessons, merong somewhat direct way kung paano natin ma-measure yung delta H nung mga reactions natin. Also, in keeping with the fact that enthalpy is actually a state function, we can now get the enthalpy of a reaction as the difference between the enthalpies of the products, final, and the enthalpies of the reactants, initial. So, since ang enthalpy ay related sa heat at constant pressure, we can then say that kapag ang ating delta H or yung change in enthalpy ay positive, it's an endothermic process kasi pumasok yung heat sa system. And if delta H is negative, then it's an exothermic process. Lumabas yung heat from our system. Okay, so let's try answering this problem. Identify whether the following reactions are endothermic or exothermic. So letter A, you have melting of ice. You have the value of delta H as positive 6.01 kilojoules per mole. Is this endothermic or exothermic? Since our delta H is positive, letter A is endothermic. So, i-check natin, kapag ba ang ice ay nagme-melt, nag-absorb ba siya ng heat or nag-release ng heat? It needs to absorb heat so that the intermolecular bonds can be broken. How about letter B? It's the combustion of methane or CH4, which will give us carbon dioxide and H2O. And this is our delta H, which is negative 890.4 kilojoules per mole. What is it? Is it endothermic or exothermic? Since our delta H is negative, then this reaction is exothermic, or heat is released by our system. So try to determine if these two equations below are exothermic or endothermic based on how the equation is written. So you determine the sign of delta H, and then you state whether it is exothermic or endothermic.